Good day, everyone. Now let us quickly solve this problem. If a car starts from rest and moves with a uniform acceleration of 10 meters per second squared for 10 seconds, the distance it covers in the last 1 second of the motion is what? Now we know that the first thing is to bring out our parameters from the question. So if a car starts from rest, anytime we see this rest, we already know that our initial velocity u equals to 0. Now, and moves with a uniform acceleration of 10 meters per second squared. We already know this is acceleration. So our acceleration A equals to 10 meters per second squared for 10 seconds. It means our time T equals to 10 seconds. Now, the distance it covers in the last 1 second of the motion. So we are looking for the distance. Now, this is going to be very useful in choosing the equation of motion we are going to use. Look at the equation of motion. Now, the equation that has all our parameters is this second equation, and that is how we are going to know which of the equation of motion to select. So, having known that, now this question is a little bit different. We need to have strategy because the question is asking for the distance in the last 1 second. We need to know what that means. Now, let me show you something. Imagine we have from 0 to 10 seconds here like this. Now, the total distance this body, this car covers from here to here is the distance in the 10 seconds because the total time taken is 10 seconds. So the total distance here is S, let me say S for 10 seconds, right? But now, let's say here now, from here to here is 9 seconds. This is 9. So the distance here, S9, let us represent the distance the car has covered in the 9 seconds. Now, the question is now asking us, what is the distance in the 10 seconds? Last 1 second. The last 1 second will be between 9 and 10. So that last 1 second is actually between here like this and here like this and this 10. Can you see? Just like you are saying from here to here. So that is what the question is asking. Now, it is very simple. If we know the total distance, that's the distance covered in the 10 seconds, we find it. The distance covered in the 9 seconds, we find it. Then we subtract the distance is covered in the 9 seconds from the distance is covered in the 10 seconds. It will only give us the remaining 1 last seconds. So that is our strategy. So now, meaning that we are going to do that separately now. We are going to do that separately. So what I'm going to do first is to find the distance is covered in the 10 seconds. So that is going to be S in the 10 seconds. That is when my time is 10 seconds now. So I'll say UT. Now, another thing is, okay, don't worry. So let's say UT plus half AT squared. So which is the same thing. I want to do this because in the second calculation, I'm not going to be showing that. So now, remember that our initial velocity is what? U is 0 if we substitute here. So that means this is going to, all of this will be 0 because our initial velocity is 0. So 0 times t will be what? Is 0, right? So meaning that we only have half times what? A. What is our acceleration? Is 10, right? So 10 times, what is the time now is what? 10 seconds, isn't it? So that is going to be 10 raised to the power of what? 10 raised to the power of 2. So which is going to be equals to half times 10 times 10 raised to the power of 2 is what? 100, right? So that is going to be equals to 2 here 1, 2 here 5. That is going to be 500 what? 500 meters. Now, we already know the total distance now. Distance in the 10 seconds. Now, let us find the distance in the 9 seconds. So that is going to be, we are going to use, I'm not going to write this now. I'll just say half AT squared to make things faster because we already know this part. U is going to be 0. So UT will be 0 like that. So now that will be equals to half times, what is A? Acceleration now is still 10, right? But our time now, this time around, is we want to stop at 9 seconds. So our time is 9. So that will be 9 raised to the power of what? 9 raised to the power of 2. So which is going to give us 10, 2 year 1, 2 year 5, right? So that's 5 times. 9 raised to the power of 2 is what? 9 times 9, which is 81, right? So 9 times 81, 5 times 1, 5, so 5, 4, that's going to give us 405. 405 what? 405 meters, right? So the distance in the last seconds will now be equals to S 10, the distance in the 10 seconds minus distance in the 9 seconds, which is going to be 500 here. So 500 minus 405. So that is going to be 500 minus 405 is going to give us 95 what? 95 meter. Thank you.